Hey, peace. All right, so I'm going to go through our second lesson here today with net ionic equations from solutions. Hopefully, you watched my video from yesterday to get a better idea of what you need to know in understanding what a dissolving equation versus a dissociation equation versus a ionization equation. Have a look at those. If you haven't yet, go back to yesterday's announcement and take a look at that. Okay, so net ionic equations. This is your second lesson. Um, so complete balanced equations or non-ionic equations. These are the chemical reactions you've seen so far. So they show all the reactants in the products as if they were intact compounds that did not dissociate in solution. Okay, so this is what you did in so far in Science 10 and what we've kind of looked at chemical reactions. Total ionic equations, though, this is some new, are more accurate representations because we learned that ionic compounds dissociate in solution. So when ionic compounds, they are soluble in solution, they dissociate into their ions. I'll show you what that looks like. Net ionic equations, this is something that's super important. Okay. You need to go through the process of understanding what this is, the complete balance, to then get the total ionic, to then get the net ionic. The net ionic shows only the actual chemical changes that occur. So this is what's showing actually occurs in a reaction. Okay. So really important just understanding what the difference is between those things. There's one more thing here that's called spectral ions or spectator ions. It's an ion that exists in the same form on the reactant side as the product side. Okay, so just as I have my spectators here, um, in some chemical reactions and lots of chemical equations, you have ions that aren't doing anything other than just being present for it. Okay? So just an example here that you can look at. This should be exactly what's in your notes. So a non-ionic equation, we have silver nitrate being mixed with sodium chromate is producing silver chromate and sodium nitrate. Okay. So same as a reaction you've probably seen before. You got silver and nitrate. It's in an aqueous state. It's being added to sodium chromate, which is aqueous. There's a chemical reaction. So we have our reactants here and then our products. And then you are producing your products here. Okay, so our products, we have silver chromate, which is one of the products, which is a solid, right? So if you can't remember, that's a precipitate. And then you have sodium nitrate, which is still in an aqueous form. Okay. So if we mix these two together, we would see all of a sudden this solid get falling out, and then we would assume that this is still in solution. Okay. So what is more accurately happening here is this, the total ionic equation. So notice how we have this guy here. We got silver nitrate. If you drop down here, there's a silver ion and nitrate ion. Okay. So ignore the two in front right now. I'll come back to that. But see, we have silver. We got silver ions. It's got a charge, and it's in the aqueous form. We have nitrate. It's an ion. If you look on your polyatomic table, it's a -1, and it's an aqueous form. Okay. So what's happening here? This is soluble in water. When it gets mixed into water, it dissociates into its ions. If we look at sodium chromate here, it's aqueous, it's soluble in water. If you look at your solubility table, it splits into sodium ions and chromate ions. Okay. Um, and yeah, so those are our reactants. So I'm going to go back here. If you look at this, here's our balance. We have two silver nitrates, we have one sodium chromate, one silver chromate, and two sodium nitrates. So we have a balanced chemical reaction here. So this too applies to all the things inside of this compound. So notice how there's two silver. We get a silver ion. There's two silver ions. We get a nitrate. There's two nitrates. Two nitrates. We've got sodium chromate. There's only one, but notice the two here. That means that there's two sodium ions. And here we have just one chromate, so we have only one chromate produced. All right. So now when we look at our products, though, if you look at this silver chromate is slightly soluble or insoluble, meaning it's a solid in water. So that means it doesn't dissociate. If we look here, see how they're the exact same? They stay as a solid and a solid. Sodium nitrate, well, that's aqueous and it's soluble in water. It dissociates into its ions. There's a two, so there's two ions and two ions. All right. Hopefully you're making sense so far. So one thing that we do now, and if my pen starts working. Okay, so when you're going through your net ionic equations, your total ionic equations, here's how we find out what the spectator ions are. If a spectator ion is the exact same in the reactants as the products, then we get rid of it. So if we look through, we see, okay, we have silver ions here. We look back on the products, no silver ions. Here we have nitrate ions. If we look on the products, we have the same nitrate ions. So what we can actually do is we cross them out. Okay, and we can eliminate them. These are our spectators, these guys. So they're not actually part of the reaction. Here we look at sodium ions. You see how there's two of them. And on the product side, we have two sodium ions. So we can actually get rid of these as well. Here we have chromate, which is an ion. And notice over here, it's not an ion. It's together in a compound. So here we have things changing. So I crossed out all my spectators. So my this is my total ionic equation. It has all my ions present. My net ionic equation is what is reacting. So we have silver changes. So that's why we put it down here. This guy came here. Then we have chromate, which doesn't or changes from reactants to products. So we bring it down here. And then we have the silver chromate, which we bring down here as well. Okay. So notice how these things, if we look at the reactant side and the product side, they're not the exact same on either one. So this is actually what's causing a chemical reaction, actually causing things to change in a solution. Okay, so that's your net ionic equation. So if we look at another example, we got a balanced chemical equation. We've got two sodium ions, two sodium iodide. We've got lead, two nitrate, and we have sodium nitrate, and we have lead two iodide. Okay. Notice our states here. This is aqueous. This is aqueous. This is aqueous, and this one is a solid. Okay. So we know that if it's an ionic compound, which we have a metal and a non-metal, when it hits water, it's going to dissociate. So my total ionic equation, we got sodium and iodine, we got sodium ions, and we got iodine ions. We have two of each, so there's two. There's lead nitrate. There's only one in front here, so we have one lead 2 plus ion, and as a result, see this 2? That's where that 2 comes from for this guy. We got two sodium, two nitrates, and then this guy stays together because it's a solid, it does not dissociate. So again, if we go through here and we eliminate our spectators, we have two sodium, and notice over here, two sodium, we get rid of them. And we look at two iodine ions, there is not two iodine ions. We have two lead 2 plus, sorry. And then if we look over here, there's no lead 2 plus ions as there are over here. There's two nitrate ions, we can get rid of those. So now what it becomes is we cross out all those. These are our reactants. This is our products. These change from one side of the reaction to the other. So our net ionic equation becomes this. Okay. Notice how we're not dropping any. We still have two iodide. We have one lead ion, and it produces lead 2 iodide in a solid form. Okay. So here's just going to be what your examples look like. And what I'll ask you, sodium hydroxide and hydrofluoric acid react. Write the net ionic equation of the reaction. You have the complete balanced reaction. You have the total ionic equation, which you split up all the ones that are aqueous. So aqueous, aqueous, liquid. That's an important one. I'll come back to that in a second. And aqueous. So we split them all apart. We got sodium ions. We got hydroxide. Okay, notice how we keep it together. We have this. All right, this is an important one. Okay. If you haven't seen this yet, this is an acid. This was in my video yesterday. This is a weak acid. So when it hits water, it does not dissociate. It stays together. This is water, and it does not dissociate. It stays in one compound. And this is sodium fluoride, which we know is aqueous and splits into its ions. So if we actually look through here, the only thing we can get rid of that's the same in the reactants and the products is the sodium ions. We get rid of that. We get rid of that. Hydroxide here, there's no hydroxide over here. Hydrogen here, there's no hydrofluoric acid. There's no hydrofluoric acid. So these ones are changing from one side to the other. So our net ionic equation becomes whatever's left over. Oh, and I can erase that. And there you go. There's our net ionic equation. Okay. So that's what the questions look like. These are important. You have to make sure you know your acids and strong acids from yesterday. You have to understand that molecular compounds do not break apart. Only ionic compounds that are soluble. So that's all for the lesson today. If you have any questions, I'll be on the forum, or we can try that virtual classroom like I said. So if you have any questions, let me know.